Going to discuss about a steady flow energy equation for an open system. An open system is a type of the system in which both energy and mass crosses the boundary at 1 and 2. Whereas closed system, mass won't cross the boundary, only energy crosses the boundary. Let us consider the examples of the open systems are: nozzle is an example of an open system, pump is an open system, turbine is an open system, compressor is an open system. The example of a closed system is piston and cylinder without valves. Now, before analyzing this open system, we have to study some of the assumptions. The first assumption in the steady flow is mass should be constant. Means mass entering at section 1 is equals to mass leaving at section 2. There should not be any interaction except work and heat. Means there should not be any interaction except work and heat. Only potential energy, kinetic energy, flow energy, Fe means flow energy, is considered. Don't consider any change in its energy because of some viscous effect like in fluid mechanics. Here, only potential energy, kinetic energy, flow energy is only considered. Now, the definition of a steady flow means steady flow is a type of the flow in which the properties do not change with respect to time at any given section. Means, if you consider at section 1, let P1 be the pressure. That pressure be 1 bar at the first minute. Let us consider after 5 minutes, the pressure won't change at section 1. The pressure always remains constant. That is the meaning of this statement. Steady flow is a type of the flow in which the properties do not change with respect to time at any given section. And for a steady flow, there is no accumulation of the mass and energy in the control volume. Means mass entering is equals to mass leaving, and whatever the energy entering is equals to energy leaving. Here we are considering energy as, let us consider U1 be the internal energy, C1 be the velocity, which results in the velocity energy or kinetic energy, PV means the flow energy, and because of the elevation at the section 1, there must be some potential energy. Likewise, and U2, C2, P2, V2 be the internal energy, C2 be the velocity, and P2 be the pressure, and V2 be the volume. Apply a steady flow energy equation, that is energy entering is equals to energy leaving. That is kinetic energy is of mc1 square at section 1. Potential energy mgz1 plus U1 is internal energy. P1 V1 is a energy caused by the flow, that is responsible for the flow. There is no P1 V1 in a closed system. U1 plus P1 V1 can be considered as an enthalpy. This enthalpy will come into existence only in open system, not in closed system, because no energy is required for the flow in a closed system. Here in open system, there must be some energy involved for this flow. U1 plus P1 V1 plus Q is equals to half mc2 square plus mgz2 plus U2 plus P2 V2 plus W, which results in half mc1 square plus mgz1. U1 plus P1 is equals to H1 plus Q is equals to half mc2 square plus mgz2 plus U2 plus P2 V2 means enthalpy H2 plus W, work interaction. If you consider it as a per unit mass, that is kilojoules per kg, half C1 square plus gz1 plus H1 plus Q is equals to half C2 square plus gz2 plus H2 plus W. So this is the equation coming from the first law of thermodynamics for a steady flow open system.